Howdy, I'm Alan, and this is our Boat Lab project. About the project. Our project is about how aerospace engineering is affected by the ocean.
The marine and coastal environment has a huge impact on the design choices we aerospace engineers make, mainly due to the high humidity and presence of salt in the air of these environments. Why is this? Well, because oxidation is accelerated by both of these things. Both salt and humidity act as a catalyst, in which actively accelerate the reaction rate of oxidation. We had to consider this in our design choices. For one, oxidation increases weight, and two, it weakens the materials we use, which could be catastrophic. On the last bulletin point, we can see an example of an oxidation reaction. Iron oxide being formed from the reaction of iron and oxygen, increasing the overall weight and reducing the strength of the structure. For this, we must consider these issues for when designing anything aerospace related. Here is the overview of what we're going to cover inside the presentation. First, we'll be discussing the placement of our groups and the roles of each of us had, specifically deliverable 1. Then we'll move on to the thesis proposals we made, and then the one we chose finally. This is both deliverable 2 and 4. To make our final thesis decision, we will present our research on the boat trip and the research we had online. Then lastly, our conclusions we can make based off of our findings.
Some issues we had during the creation of our projects were scheduling conflicts and selecting a final thesis given the conflicting natures of our ideas for our thesis. We solved these issues by planning dates far in advance to ensure we would all be available to work on the project, and also by combining different parts of our theses to create a new one that best satisfies our ideas.
Project members. There were 4 of us, and I was team manager, so I made sure the presentation was informational and professional.
Howdy, I'm Nicholas Reinke. I'm the team facilitator. My role was to make sure my group was on track time-wise. For this, I scheduled meetings to discuss with the presentation and make sure everyone was on track with assignments individually.
Howdy, I am Luis Jankowski and I'm the product manager. My job is to ensure that all the criteria is met for the project, and I guided the presentation content, made sure the team is setting all the objectives, and also made sure the team chemistry is good.
Hello, my name is Miguel Cabrera, and I was the research facilitator for this project. I helped to make sure that all of the sources were credible and verifiable, along with helping find sources myself. To start off with, we will be demonstrating our 5 original thesis ideas.
Our first thesis says that aircraft need to be designed with ocean-related properties in mind so they can float. This involves figuring out what materials provide the best buoyancy. This is important because planes should be designed so that they can handle a water landing, whether intentional or unintentional.
Here is our second thesis. Coastal humidity increases the risk of corrosion, so aerospace engineers must determine what materials and mixtures are the most resilient to rust. So, as you can see inside the photo, there is corrosion on the boat. This is an example of why we need to research to find stronger materials.
Our third thesis says that aerospace engineers must study how the chemical and behavioral properties of water relate to the behavior of air in order to improve aircraft design. This includes looking at things such as the humidity and condensation and their effects on aircraft. Our fourth thesis says that because aerodynamics are similar to water dynamics, aerospace engineers can use their knowledge of ships and submarines, mainly what makes a ship hydrodynamic, and also apply that knowledge to airplanes to make them very aerodynamic.
Thesis 5. Since colors get harder to see from far away because of the atmosphere refracting light, what color would stand out the most from far away? Final thesis. We ended up using the second thesis and slightly changing it just a little bit, because from our boat lab, we had a lot of evidence to help support this thesis.
How did we come up to the conclusion to choose that thesis? Well, we did this through our thesis proposal research. One of the ways we researched to choose a thesis was through the boat trip. On this trip, we traveled to 5 different locations. Using these locations, we can pinpoint real examples and issues that could be improved. And the map provided are the places we visited with coordinates representing each. We will cover deeper of what we found inside each location as well.
For the first location of the boat trip, we went to the Gulf Copper. At the Gulf Copper, there was an oil rig and also a rusty dock. The metal parts of the dock were corroding, which was causing it to fall and sink into the water a little.
The second location we arrived at was the Royal Caribbean Cruise Terminal. Royal Caribbean spends a large amount of money to prevent corrosion on their ships, highlighting the importance of preventing corrosion. The terminal supports are also mostly built with materials that don't corrode. The third location we arrived at was the wreck of the SS Selma. The ship was largely made out of concrete with metal supports on the ship. Large amounts of corrosion are visible on the ship, and several parts of the ship have been broken due to corrosion. This shows the scale of damage that corrosion can cause if left unchecked. The fourth location is the Pelican Island Cut. The Pelican Island Cut is a bridge that connects Pelican Island with mainland Galveston. Given the fact that its supports are continuously underwater, the supports are designed with materials which don't corrode easily. The fifth location is the Texas City Refinery. The refinery had a chemical leak due to unmaintained corrosion, and also the heat from the marine environment contributed to the disaster. This further shows the disastrous consequences that unmitigated corrosion and bad adapting to the marine environment can have.
We also did research online that supports the thesis as well. Our first source covers an airport in Mauritius. This airport is an exact example of a coastal environment, being only 250 meters away from water. On the paper, they researched the impact of corrosion and the decisions that the airport makes. They spent over $200,000 per year to fix corrosion on the airport. Even then, they cannot fully prevent it from happening and only could delay its effects. Aluminum 7075, a material often used for airplanes, was shown to have massive amounts of corrosion. Without considering the environment and how it impacts corrosion on the airplanes, it could lead to deaths and significant loss.
The research paper I looked at tested two types of aluminum alloys, and by using potentiodynamic tests, figured out that an increased iron content affected the microstructures of the alloy, which allowed for corrosion to occur faster.
According to Zhang et al.'s paper titled Corrosion and Aging of Organic Aviation Coatings, a Review, aircraft coating helps prevent corrosion in several ways. For one, it reacts with water to form a protective coating against corrosion. This, along with the coating itself, helps block corrosive metals from directly hitting the actual metals inside the aircraft, reducing corrosion. The coating is also designed to adhere well to the metal to prevent peeling under the rough conditions that aircraft fly under.
So, in one of the papers in our research, it found that aircraft operating in marine environments are exposed to factors that accelerate corrosion. This necessitates certain considerations from aerospace engineers. Marine environments are dangerous because they contain electrolytes like chlorides from salt solutions. This is harmful to aircraft structures made of aluminum or other susceptible materials. The corrosiveness of the environment is influenced by the shore, waves, humidity, and winds. The most corrosive factor in the air is salt. A constant exposure to salty air and high humidity requires that aerospace engineers add corrosion resistance and waterproofing into aircraft designs.
In our project, we have used academic papers and analysis of our boat trip to prove that aerospace engineers must develop materials and methods to reduce the harmful effects of corrosion on their aircraft. The issue of corrosion will likely continue to be an issue requiring special attention from several industries, including the aerospace industry, to prevent financial or catastrophic losses. Although the issue of corrosion will likely remain, as time moves forward and engineers continue to invent better solutions, these issues will continue to be easier and less costly to deal with. Here are our sources for our project. And thank you for watching our presentation. I wish you a wonderful day.